The next question is to convert the following NDFSM to its equivalent DFSM. And the NDFSM is given in the form of a transition table. In the step 1, we are supposed to compute the EPS of all the states present in NDFSM. To start with, EPS of P. By default, P will be in the EPS. From P, for epsilon, it is going to state Q and R. So Q and R also are included. EPS of P is equals to PQR. Next, EPS of Q is equals to Q. And if you see here, there is no epsilon transition from Q to any other state. So EPS of Q is equals to Q. Similarly, EPS of R is equals to R, as R doesn't have any epsilon transition. So once we have obtained the EPS for all the states, in step 2, the new start state of the DFSM S dash will be EPS of the start state. And here the start state is P. So EPS of P is equals to PQR. So the new start state of the DFSM will be PQR. And at present, the active state is PQR, and we are supposed to obtain the delta transitions for this state PQR. So PQRA, see this column, we have null P null, that is P. So EPS of P is equals to PQR. Next, PQRB, all the three here. So in this column, it goes to QR. EPS of Q is Q, EPS of R is R. So PQRB is going to QR. Next, PQRC. This column, we have PQRC going to state PQR, and EPS of PQR is PQR. So after computing delta transitions of PQR for input symbols A, B and C, we have seen a new active state QR, and the current transition diagram looks like this. Initially we have state PQR. For A and C, it is going to self loop PQR, and for B it is going to new state QR. As of now, the active states are PQR and QR. For PQR, we have obtained the transitions. Next, we are supposed to obtain the transitions for QR. So QRA, we have P and null. EPS of P is PQR. QRB is going to R and null, so it is R. EPS of R is R. So QRB is going to R. QRC, Q and R, C is going to PQ and null. So PQ. EPS of P and EPS of Q will get PQR. So QRC goes to PQR. So from this we can see a new active state R generated. So the current transition diagram looks like QR, A and C is going to state PQR. For B, it is going to state R. Now we are supposed to compute the transitions for state R. You can see here RA, RB and RC all are going to null state. And here we don't have any change in the active states. So the deltas has been computed for each elements of the active states. Hence this is the final DFSM obtained with three states PQR, QR and R, where all the three are final states, because in the NDFSM the final state was R, and in DFSM wherever you have R, all the states will be final states, and here all the three states have R, so all the three are accepting or final states. So this is the DFSM obtained for the given NDFSM.